Hi, welcome to Geometry. We are going to be talking about intro to proofs. What is a proof? You'll see that right here, what a proof is. Let me point to it. There you go. First thing we're going to talk about are different properties and rules that we can use, because in a proof we're going to have to justify every step. Here we have the addition property of equality. Equality just means that whatever we do to one side, we'll do it to the other. So if we add 5 to both sides, see what we get. We get x is equal to 17. How do we justify that? It's called the addition property of equality. Next one is the subtraction property of equality. So what we're going to do is we're going to subtract 6 from each side. And what can we conclude? That x is equal to 9. All right, here we have the multiplication property because we are going to multiply both sides by 5 times 5, and that'll give us x, and this will give us negative 10. So what we can conclude is that x is equal to negative 10. This is the division property of equality, and we divide both sides by 2, and we get x is equal to 4, and that's what we can conclude. Here we have y equals 2x plus 2 and x is equal to 5. This is going to be substitution, so we're going to substitute 5 for x, and we get 2 times 5, which is 10. So y is equal to 10 plus 2, and so therefore y is equal to what? 12. What can we conclude? That y is equal to 12. All right, if you take a look at this, we have the reflexive property. 30 is equal to 30. Anything is equal to itself is a reflexive property. If we turn things around and let x come to this side and 5 go to that side, that's the symmetric property. Notice we have j and j here in the middle, so we can conclude that y is equal to negative 13. Here we have the distributive property. 12 is equal to 3 times x plus 3 times negative 9. That's the distributive property. Here, we're going to be simplifying and combining like terms. So y is equal to 12 minus 12. So y is equal to 0. Sometimes we just simplify or combine like terms. Here, same thing. We have 45x minus 20x. So 100 is equal to 25x. And if we divide both sides by 25, we get x is equal to 4. So not only did we combine like terms, but we also did the division property. Here we're going to justify each property. In other words, we're going to say what just happened. So in order to go from 6x plus 2 equals 12 to 6x equals 10, we notice that we're losing a 2. So what just happened? We subtracted 2 on each side. What property justifies that? We'll say the subtraction property of equality. Looking at number 2, 45 is equal to x. And notice that we switched this around. This is the symmetric property, and x is equal to 45, and we'll call that the symmetric property. Here we have 3x minus 7x equals 20, and that goes to negative 4x equals 20. What just happened? We combine like terms. Sorry about the handwriting. Last but not least, a two-column proof. A two-column proof will list, let me underline that, each statement on the left with a justification on the right. Each step follows logically from the line before it. Fill in the missing statements or reasons for the following two-column proof. Okay, so the first line tells you everything that has been given. The second line tells you what you must prove. So it's like a recipe. We start here, and when we finish the cake, we should be at the end. So 45 plus 2 times the quantity, x minus 10 equals 85. Looks like that was given to us. Now, what's happening from here to here? I noticed that the 45 isn't there, the 85. So we subtracted. This is the subtraction property of equality. Okay. Now, when I notice what happened when I went from line 2 to line 3, going from line 2 down to line 3 had parentheses. Parentheses are gone. Oh, that is the distributive property. Now, let's take a look and see what happened as we went from line 3 to line 4. The minus 20 is gone, so we added 20 to both sides, and that is the addition property of equality. Next, as we move from step 4 to step 5, what do we see happening? We see that the 2 is missing, so we divide it by 2, and that is the what? The division property. Okay. So basically, that's what proofs are. We have to justify every little step. Thank you for listening.